We're using the J-purlin in our VP series of buildings. This is a proprietary design that's unique to Calhoun and was developed with the loading that it experiences in the building in mind. We spent a lot of time focusing on the branch connection between the web and the chord, and there's a very unique bracket that's put in place there, and that's really been put in place to align the lines of action between each of those members. And what that does is produces a very efficient branch connection that eliminates any secondary bending in the chord of the truss, and this allows us to make best advantage of the chord material and use it to its fullest. For the VP series of buildings, these are larger projects. The customers are looking for a high degree of configurability, so we've incorporated our standard pitch, which is a 7/12 pitch structure where a high roof line is desirable. We have other applications where the customer doesn't need that extra roof height, so we have a low slope variant with 4/12 pitch. And we also have a variant wherein we can mount the buildings on a slender column or an I-beam to give lots of variations depending on what the customer is going to look for. If we look at the overall shape of the VP truss, we do have what we call an optimized profile, where we've actually tapered the truss section. So you'll see near the shoulder and the peak where the demand is highest in the truss, we've made that section a little bit deeper. It allows us to move the material to where it's most required and make the most efficient use of our material. And in those slender sections on the main part of the roof slope, we don't require that amount of material. So that allows us to produce the most efficient structure we can and reduce the overall cost for the end customer. We're now into structures that are 200 feet wide, clear span, and we're routinely building structures 160, 180 feet wide. All that basis of engineering that we've built up over time has allowed us to really spread out our capacity and go to these larger and larger structures. We're working on even the next generation, even though we're just now producing our third generation of these structures.